How does NASA send its rovers to Mars? Well, there are 4 stages involved, and we will take a closer look at each of them now. The first stage is the pre-launch, which is where they get everything required sorted out and ready to successfully carry out the Mars mission. It includes major activities such as landing site selection, where scientists decide where to send their rover so it can best land, work and discover on the red planet. They don't want to land their rovers on high elevation sites where there isn't enough atmosphere to slow the spacecraft down, or land it on places with steep slopes and big rocks where it would be hard to drive. They also don't want to sink it through layers of sand, which can cost them billions of dollars. It is best to land at the equator, where seasons aren't so extreme and solar panels can get a lot of sun, thus making working there easier. NASA uses satellites like the Mars Reconnaissance Orbiter, MAVEN, or the Mars Artesia orbiting Mars to collect lots of data about potential landing sites, which are then narrowed down to 1. The landing site selection for the Curiosity rover spanned a whopping 5 years, and a list of 100 potential landing sites were narrowed down to 1. The second major activity is assembly and testing of the rover at Jet Propulsion Laboratory. In this activity, various instruments and technology that are vital to the mission are assembled to create the rover and spacecraft, which are then put through rigorous environmental, electronics, software, and systems testing in the cleanroom at Jet Propulsion Laboratory in Pasadena, California. Here is an example of what it might look like. After assembly and testing comes the third activity, shipping the spacecraft to Cape Canaveral. After months of building and testing, the rover and other necessary technology like the spacecraft are disassembled and carefully packed for travel across the country from its birthplace in California to Kennedy Space Center in Cape Canaveral, Florida. After the spacecraft and other necessary technology like the rover are shipped to Cape Canaveral, they are assembled and tested again at Kennedy Space Center. Considerable amount of work and countless hours are put in by engineers at the Kennedy Space Center to reassemble and test the rover and spacecraft, finally preparing it for launch. While the rover is undergoing its final assembly, NASA picks out what rocket it is going to use for launch. Obviously, really powerful rockets are used to launch the spacecraft carrying the rover into space. These rockets have to be going at least 25,000 miles per hour or more to do so. Keep in mind, NASA doesn't just choose any rocket for missions, but determines what rockets to use by considering their weight, capacity and other features, as well as the requirements of the payload, which in our case is a rover. Some rockets that have carried out previous Mars missions include Atlas V541 used to launch Curiosity, or the Delta II rocket used to launch Spirit. But there are a few other important steps NASA scientists take before launching. They calculate the best launch time and route that would take the least amount of time and fuel to get to Mars. This time usually comes about every 26 months, when the 2 planets are aligned in a way that allows for the most energy-efficient trip to Mars. This efficient route is known as the home and transfer orbit, and it is often the go-to transfer orbit for landing on Mars because of its ability to consume the least amount of propellant possible. After everything's worked out comes the second, and one of the most intense stages in rover's journey, the launch.
7, 6, 5, 4, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build, resupply, and to do research on the International Space Station.
Houston now controlling. Atlantis begins its penultimate journey to shore. Earth's 8.5-minute ride to orbit, 4.5 million pounds of hardware and humans taking aim on the international outpost. 30 seconds into the flight, Atlantis almost 2 miles in altitude, 6 miles downrange from the Kennedy Space Center, already traveling 500 miles an hour. 3 liquid fuel main engines now throttling back to 72% rated performance, going into the bucket, reducing the stress on the shuttle as it breaks through the sound barrier.
Once the launch is successful and the spacecraft aboard the rocket escapes Earth's gravitational pull and enters space, it separates from the rockets and enters the cruising stage of its journey. From here on, it will travel 300 million miles, or 480 million kilometers towards Mars in the home and transfer orbit, which will take approximately 6 to 8 months give or take. During this flight, engineers on Earth make sure the spacecraft is functioning properly by performing tasks like checking spacecraft health and maintenance, monitoring and calibrating the spacecraft and its onboard subsystems and instruments, performing attitude correction turns like slight spins to keep the antenna pointed toward Earth for communications and to keep the solar panels pointed toward the sun for power, conducting navigation activities such as trajectory correction maneuvers to determine and correct the flight path and train navigators before atmospheric entry, and last but not least preparing for entry, descent, and landing (EDL), and surface operations, a process which includes tests of communications, including the communications to be used during EDL. The entry, descent, and landing (EDL) stage begins when the spacecraft enters the Martian atmosphere. The spacecraft carrying the rover is traveling across the Martian atmosphere at speeds of thousands of miles per hour. The EDL phase lasts for around 7 minutes and is the single most intense and terrifying part of the spacecraft's journey. It has to safely go from those speeds down to zero in a short amount of time, while still managing to hit a narrow target on the surface of an unexplored and uncharted territory. Even with the highly precise guided entry system, the mission team can't tell if it's going to land on a tilt or a bump. To get an idea of how hard it is to land on Mars, consider this: only about 40% of the missions ever sent to Mars by any space agency have been successful. And to make it even harder, when the spacecraft enters the atmosphere, it loses radio connection with the mission team on Earth. And even after it lands and establishes radio connection, it takes about 11 minutes for signals to reach Earth. So by the time the mission team hears that the spacecraft has entered the atmosphere, in reality, the rover has already spent 11 min on ground. As a result, spacecrafts are designed to complete the EDL phase automatically on their own. As you've seen, to slow down and land safely, spacecrafts use a combination of rockets, parachutes, and cranes to slow down and land safely. After a few terrifying minutes, touchdown. The rover has completed its journey from assembly and testing in California to landing on the Martian surface. Once landed, it establishes radio connection with Mars satellites like MRO or MAVEN. After receiving the signals, mission team then performs checks to see that everything is working the way it should. There you have it, that's how NASA gets its rovers to Mars. If you found this video useful, please like, share, and subscribe with notifications on so you don't miss any of my upcoming videos. If you would like to put any suggestions in the comments, that would be very much appreciated. Thank you.